Hello everyone, welcome to this session on network intelligence as a part of course Marketing and Social Media Web Analytics. I am T. Shiva, Assistant Professor in the Department of Computer Science and Business Systems in Tyagaraja College of Engineering. Today we are going to explore how network works, how they grow, and how these principles helps us understand social media behavior and online communities. In this video, let us see the glimpse of these and we will explore it further in the upcoming videos. In this video, we are going to get familiarized on the following topics: what makes network a network, metrics, communities and clusters, link analysis, random graphs, preferential attachment, network growth, and hands-on demo. What makes a network a network? A network is a collection of nodes and edges. Nodes represent entities such as people, accounts, websites, or devices, and edges represents relationship between those entities like friendships, followers, communication links, hyperlinks, etc. Networks appear in social media platform, transportation routes, communication system, and more. Understanding these networks helps us analyze interaction, information flow, and influence. Why networks matter? Networks reveal hidden patterns that raw data cannot show. They help identify influences, nodes that give high impact on spreading information and help predict behavioral trends. In marketing, network analysis is essential for advertising for audience targeting, viral content predicting, and community behavior understanding. Meet your metrics. So number of direct connections to a node as a high degree node are usually influential. That is called degree. Betweenness and centrality means measures how often a node lies on shortest path between others and identifies the bridges between nodes. Closeness means it indicates how quickly information spreads from a node. Centrality means measures influence based on only one number of connections but their importance. Density describes how tightly connected a network is. These metrics transforms complex networks into understandable patterns. So we will study about these particular metrics in the upcoming video detailing. Communities and clusters. Communities or clusters represent group of nodes that are more connected internally than externally. Detecting them helps identify cluster segments, interest groups, and behavior based cluster. Algorithms like Lowian method and modularity optimization help detect these communities. Why communities matter? Communities allow marketers to perform targeted campaigns, understand behavioral patterns, identify echo chambers, and detect fraudulent or bot clusters. Understanding community is a key to understand your audience more deeply. Power of link analysis. Link analysis focuses on relationship between nodes. It helps detect fraud, analyze influence, and track how information flows. Google's PageRank is a classic example of link analysis used for ranking website. In social media analytics, link analytics identifies influential accounts and content propagation patterns. Random graphs. Random graphs are edges, the ER model, connected nodes randomly with the probability P. They create networks with predictable mathematical properties such as Poisson degree distribution. Although they are not realistic for social behavior, they help establish theoretical baseline. Random graph limitation. Random graphs have no clustering, no hub, and do not represent real social networks. They fail to model popularity, influence, or community information. Preferential attachment. Preferential attachment explains real-world network formation. Nodes that are already popular attract more connections. This high rich get richer behavior leads to scale-free network. It explains why celebrity account grows quickly and why viral content spreads rapidly. Properties of scale-free network. Scale-free network have hubs. Nodes have extremely high degree. They are robust to random failure but vulnerable. If hubs are removed, these properties explain real-world phenomena like system failure and attack vulnerabilities. Network growth and evolution. Networks consistently grow as a new node join and a new relationship form. Growth is influenced by geography, interest similarity, and platform algorithms. Understanding growth patterns help interpret how communities and influences form. Network maturity stages. Networks typically pass through emergence, small cluster form, growth, rapid expansion of nodes and edges, stabilization, networks become structured, maturity, hubs and communities stabilize. Understanding these stages helps predict further trends. Hands-on network intelligence. Tools like GP, Keystoscope, and Python's Network X enables visualization, simulation, and measurement of network structures. These tools allow analysts to work hands-on with real-world network dataset. Demo workflow. A typical workflow includes import data, build graph, compute metrics, detect communities, visualize structures, interpret insights, and this follows converts raw data into actionable decisions. Marketing insights. Network insights helps detect audience clusters, identify bridges, users, highlight influencers, and improve content targeting. These insights help optimize marketing strategy and increase engagement. Case study. A real-world case study may involve identify high connected user with a cluster. Using centrality metrics, we find influencer of group. This helps determine who to target from promotion or campaign. Now let us see a pre-quiz on this model, the topics we are going to explore further. First question is, in social media analytics, what does a node typically represent in a network? The options are an advertisement, a person, page or account, a device, or a random algorithm. The answer is a person or a page or an account. That is considered as a node in a typical graph network. What does an edge indicate in social network graph? Is it a computer error, or a connection or interconnection between two nodes, or a financial transaction, or a cluster of unrelated topics? The answer is B, a connection or interconnection between two nodes. Third question, which matrix helps identify the most influencer user in social network? The options are clustering coefficient, degree centrality, random walk length, page load time. The answer is degree centrality. What is a community in network intelligence? Is it a random set of users? Users grouped by similar follower count? A cluster of nodes more tightly connected to each other than to others? Or a list of trending hashtags? The answer is a cluster of nodes more tightly connected to each other than to others. Why are social network graphs useful in analytics? Is it the platform look attractive? They visualize hidden patterns or influence and connection. They are required by all social media companies, or they replace the machine learning models. The answer is they visualize hidden patterns of influence and connections. So in this model, these are the upcoming videos we are going to study. In the video 1, we will explore on the topic of what makes network a network. In video 2, we will explore meteometrics, how connections tell stories. Next, we will move on to communities and clustering, finding hidden tribes. Then the power of link analysis. Then we will explore about the random graphs, networks born in chaos. Then we will study about the preferential attachment, the rich get richer effect. Then we will move on to the network growth and evolution. Then hands-on network intelligence. So thank you for joining the 30 minutes overview of network intelligence. These principles helps understand how social media platforms operate and how information spreads. I encourage you to explore network tools and apply them in your marketing analytics journey. Thank you.